Okay. So first, we're just going to briefly look at functions of several variables. In the first two examples here, we just basically find specific function values of points, and I think just quickly looking at this, x squared plus x times y cubed. If you have 0, 0, that'll all be 0. It continues on. I don't think there's much to talk about, but it's here if you want to look at it. But you just plug in the values given for this type of situation. It's more of a thing just to understand how, like, when you have more than one variable in a function, just a quick refresh on the idea that you do have to be considerate of what's going on, in the problem. In the function itself, certain things can be different than what it's not as simple as one variable. But, and here's another look at it, continuing. Just plugging in those function things. I don't think that's a big issue. What might be is more about finding, sketching the domain for each function. So we have two. So this one is x minus 1, y plus 2 over y minus x times y minus x cubed. So y equals x cubed and y equals x will be where the denominator can be 0, because one of those equal to 0 is in the whole denominator is. And that means that's where the domain cannot exist, is where the denominator is 0. Pretty much you won't have, it doesn't, the domain, you can't put anything in there that leads to an undefined function, basically. That's the main idea behind domain here. So it's the graph of y equals x, y equals x cubed. This, all points x and y not included on, it can be everything besides those. And in pink is what those graphs look like, the simple lines, and everything else in purple is what it is. The domain is everywhere except pink. That's the whole idea. You just have to be able to think a little bit about that. And this one is a little bit more tricky somewhat. It's using your trig ideas. It's y minus x squared, the inverse cosine of that. Y minus x squared. So it's the range. So domain of the inverse cosine is the range of cosine, is how I think of this. So cosine theta is anywhere between -1 and 1. That's all you can get out of that function. So extrapolating this further, you have, theta is equal, theta would be, we have basically y minus x squared as theta, so basically it's -1 unless it has to be greater than or equal to -1 and less than or equal to 1. This expression, so you basically add x squared to both sides, then you can see y is in between. So its domain is xy coordinates satisfying this condition that x squared minus 1 is less than or equal to y, which itself is less than or equal to x squared plus 1. So we just added. That's kind of the way you approach it if you really asked about domains and ranges and all that. You figure out these ideas. But we have one more idea involving all these ideas. So for this function, we have two functions to look at. This first one is somewhat simple, y minus x. It's a very simple two-variable function. The domain is all points x, y, and xy plane, which is obvious because you can plug in any value and it'll be defined for it. Any x, y points. The range is, of course, all real numbers as a result, because of the simplistic nature of it. Y minus x equals c is just the form of all level curves, because a level curve is where the function has a constant value. No boundary points. There are no boundary points to this, as the domain has all points x, y, and xy plane. Domain is open and closed because of unbounded domain as its extreme entire xy plane, so it won't be bounded, obviously. It has no boundary points. It's unbounded. It's open and closed because it includes, all the you can go into theory behind it, but the domain will include pretty much every point. So I think as a result of it includes everything. It'll be open and closed. But I think the next example demonstrates this better. So final one of this section. We're trying to keep this short because there's not much to really talk about. This is if you were actually expected to do a lot of more theory involved in a Calculus 3 course, you might involve more of this, like have to understand what's going on in higher dimensions. It's just more of trying to get a feel for what goes on in more complex functions. F of xy equals 1 divided by the square root of 16 minus x squared minus y squared. The domain is all points x, y satisfying x squared plus y squared less than 16. That's because you set this, it has to be greater than 0. Because square root has to be positive, or 0. Basically it can be 0, anything greater than or equal to 0. Because it's the denominator, it has to be greater than 0. In that case. It can't be equal to 0, so altogether greater than or equal to 0 becomes greater than 0 because it can't be equal to 0. And that's true basically, you add to that sides and you switch the sign to get x squared plus y squared less than 16 instead of x 16 greater than x squared plus y squared is the same as x squared plus y squared is less than 16. And that's where your domain will be, everything that satisfies this condition. And the range is everything, like the function itself value, let's say z is f is equal to f of x, y, the function itself. Z all real is in real numbers, all real numbers, z greater than or equal to 1/4. And 1/4 is gotten by this calculation here, because you basically assume the lowest value of this function will be when the denominator is its largest value, because division by a larger number produces a lower number, small number, when the numerator is constant. So the point of this problem is how that's figured. How you figure the maximum value is when x and y would be 0, because when you square, it's subtracting squared numbers, so those will always be positive. So 0 would be the greatest, So when it's just 16, so its square root of 16 is 4. 1 divided by 4 is lowest z value. And level curves are circles centered at origin with radius less than 4, and you can get this less than 4 based on that square root of 16 thing basically. And you solve, you get x squared plus y squared equals k squared, which is a circle, I don't think it's that important though. You can look at this a little bit and figure out what's going on. I'm trying to this is like the math kind of behind it, but there's not much here. Calculation wise, it's just trying to explain its calculations. Level curves have to be a constant value though. In the end you can see you equate, because you're basically setting this function equal to the constant c. But the boundary of domain is something more interesting to talk about. It's x squared plus y squared equals 16, because that's a boundary point. It can't equal that. But your boundary point can be basically it's where, but nothing can go beyond it. It can't be less than that. Domain is open and bounded. It's bounded because obviously it has a boundary point, and it's open because it's everything beyond it. And it's everything included in that region that's bounded. So it's hard to explain, but I hope this at least tried to clear it up, besides what other people would try to teach you. As I said, this thing is not the most important topic, it's just to give you an idea of it. How several variables we can talk about.